For our project, we looked at remediation for contaminated sites. Our group consists of Connor Cordova, Jordan Finley, Johnny Ho, and Sarah Lee. In our project, we looked at an inactive landfill which now has outflowing toxic waste into the environment, and there is a body of water that is vulnerable to these toxic wastes. Our constraints include that there is an aquifer made of sand and silt. The hydraulic conductivity is 43 feet per day. There's a recharge of 5 times 10 to the negative third feet per day with a porosity of 0.1, and the thickness of the aquifer is 140 feet. We plan to look at preventing further contamination by the landfill to the surrounding bodies of water. The models will help determine which of the methods, such as an impermeable cap, a slurry wall, and a drain, which one will be the most effective in preventing the further contamination. In this presentation, we'll look at the remediation alternatives, their results, and our group will place recommendations of which will be the most useful. And we will also look at the effectiveness of this recommendation. Furthermore, we will also look at recommending improvements to this project and how it can be extended. The following are the alternatives that we modeled. Most of our alternatives build off one another. We began modeling a do-nothing scenario which left the landfill site as is. And then we began to look at placing an impermeable cap, then building off of that by adding a confining wall. From there, we did an impermeable cap with a slurry wall and drain. Our next alternative was looking at a slurry wall with a well. And then lastly, we looked at a slurry wall with a well and with a drain. From these alternatives, we focused on choosing 3 of them that decrease the particle travel time and decrease the outflow to the constant head boundary in the river. Next, we will further look at these 3 specific alternatives.
In one of the models we're viewing in depth is the impermeable cap. The impermeable cap prevents recharge in the landfill area. So in the model, the recharge is set to 0 in this particular area as shown on the display. The results from this model are displayed. The constant head boundary is equal to 188,000 cubic feet per day. River outflow is equal to 40,600 cubic feet per day. And the medium particle travel time is 12,400 days. The other alternative we're looking over is called the slurry wall and well. The slurry wall keeps water from outside of this area from coming in. The well that is installed into this particular site drains all the water and toxins out of this site. The flow rate that we set in the model for the well is negative 20,000 cubic feet per day, and the results are given in below. Constant head boundary is equal to 192,000 cubic feet per day. The outflow to the river is equal to 19,200 cubic feet per day, and the median particle time travel is 576 days. In this third alternative, we are combining the slurry wall, impermeable cap, and drain as an alternative. The slurry wall will prevent water from outside the area from coming into the area. The impermeable cap prevents recharge in the confines of this area, and the drain will carry and contain what is coming from the landfill. So the toxins and water already inside this particular area will be contained in that drain and carried out. The results from this model are displayed. The constant head boundary is 180,000 cubic feet per day. The outflow to the river is 13,800 cubic feet per day, and the median travel time is 491 days. and the model is displayed on the right. When comparing these alternatives, we look at 3 criteria. 1, cost. 2, particle travel time. 3, outflows. The first one is impermeable cap. The advantage is cost benefit when you compare it to the other 2 alternatives, because when you lay a fill over a plot of land, it will be expensive, but it won't be as expensive as installing a wall 10 feet deep. The disadvantages include toxins are still able to freely move through this particular site. For the slurry wall and well, the advantage is initial installation costs will be pretty low, but a disadvantage would be the cost of well maintenance over time is expected to increase. For the slurry wall and cap and drain, the advantage is a decrease in particle travel time, but a disadvantage is costs associated with installing drains and water treatment. A disadvantage would be cost of well maintenance will be high due to the high flow rate used. Will be expensive over time.
Out of these 3 alternatives, our team recommends utilizing a slurry wall, an impermeable cap, and a drain. With this alternative, this decreases the outflow of the constant head boundary and river. This also decreases the median particle travel time and allows for the groundwater to be carried away from the landfill. This also, from looking at the other alternative, had a higher decrease of the parameters we were looking at, which were the outflows and the particle travel times. And the cost of installing and maintaining the drains would be lower than that of a well. In summary, this project allowed us to learn how to utilize the groundwater vistas to model remediation alternatives. The alternative that we had chose reduced the value of all the parameters of interest. Another way that we can improve on this project is looking at different variations of remediation alternatives, perhaps exploring other alternatives such as excavation and disposal or soil vapor extraction and others.